Hi, my name is Nathan Stacy, and I want to welcome you today to our presentation on data mesh, real-time situational awareness. Data mesh, very common discussion right now. We've been in this world for a while and wanted to show what we're doing with it, but also why the value of data mesh exists in our terms. I think there's some incredible white papers out there that exist that have shown the history of data lakes. I would highly recommend looking at some of those. I can't remember her name. She name starts with a Z. She's kind of created that concept. But I want to talk about why there are so many data stores out there, why we're fine with each other, and from there, how we can utilize that for a speed layer within Elastic. So a little bit about me. So I'm a solution architect. I spent most of my time with the Air Force team here at Elastic. Again, happy to meet you guys. Happy to meet everyone here. As Jay-Z, the great Jay-Z commonly says, you could be anywhere in the world and you're with us today. I appreciate that. And feel free to reach out. I would love questions. Feel free to stop me as we go along and discuss this topic. I'd love to hear some use cases. I would love to hear where you might be seeing some of these things, where anything along those lines. This is a community. It's good for us to kind of hear from each other, to hear what's happening, and we all have our own domains. We're all working on hard stuff, and sometimes it's good to hear someone else and see what's happening on the other side. So as I go through, as I talk through this, we are going to talk through 4 different components. First, the type of data stores, why there are so many. We are one, but there's many out there. How we utilize the data ingestion and normalization components, correlating that data, and then we're going to have an actual demo from there. So Elastic is all about speed. We are a data store, and there are many use cases for Elastic. There are many use cases for many data stores out there. When you go to a trade show, you will see many of us and RMDBs and NoSQLs and big data and kind of file storage. There are many different kinds of us, and there's a reason for that. And as we look at all the different use cases that exist, the value is that we all exist for different usages. So originally the reason why this was the case was the CAP theorem. So when the database concept came out in around the 70s, 80s timeframe, the main one that existed was RDBMS. That's your classic. I'll walk through the names, but the classic databases that we have known for a long time. We've learned pretty quickly that you cannot do everything with a single type of database. There are 3 areas: availability, consistency, and partition tolerance, that you can only have 2. You maybe only have 1, that you're not going to go that far if you only have 1, but at most you can only have 2. You have to accept that you can't have them all. And so originally it was availability and consistency. That was our big key. That's what we had the capability for. We did not have partition tolerance. That's where the Cassandra Couch DBs and the big tables started coming in. But again, they had to decide which they didn't want. Did they want to make sure the data was available? Did they want to make sure the data was consistent? What does consistent mean? If you want 99.99999% consistency as opposed to maybe just 3 nines of consistency, availability, the same deal. You can get really good, but you can't have it as good. That's the issue. As we start moving into the big data world, there's a new kind of CAP theorem that we are starting to build. And I really like how this one was built. The CAP theorem is very formalized. A lot of people are very well respected. We haven't quite defined the concept as big data, but I liked how this one showcases where you have to choose between variety of data. As you're bringing in data, do you want just fields, or are you looking for videos? Are you looking for songs? If you're going to look for those things, then you have to choose between the quantity of the data or how fast the data comes in. Think of like a stream. Can you bring in a lot of data fast? That would be velocity. How much data you can hold? That would be volume. And so you have to pick and choose between these three things to help you understand what you're going through. So let me go through the actual databases that exist and we can talk through them. The first one, the OG, would be the RMDB. And I remember I kind of geek out on these things. And in the 80s, there was this video that was created by the guy who started Slashdot. Very entertaining if anyone wants to look into it. And he interviewed the people who made the first spreadsheets, the first databases. And they said that they would go to conferences, and he said, I mean, this is basically how he said it. They would stare at what we would show them in the demo, and they would basically just give us their credit card and say, I don't care how much it is, just give it to me. I mean, you could imagine how revolutionary this was at that time to be able to build these spreadsheet-like fields together. Here is a dog, name, kind of food they have. Are they a good boy or are they a bad boy? Another spreadsheet that would showcase what's their tag number, what's their breed, color, age. Being able to look at large scale data sets, be able to pick and choose, to be able to do these searches of this kind of data, revolutionary. Nothing ever existed before. As I kind of think about that, I just can't imagine being able to have that kind of knowledge. The huge value of this, back to that CAP theorem, is it's very good for very structured data. It's very good for if you need to make a change, not a big issue. If you need to add a new dog to this, not an issue. If you need to look back and say, you know what, maybe Rex actually needs dry dog food, not an issue. That's the value of this. But because of its structure, because of its ability to make those CRUD, create, read, update, and delete type things, it really is not good above about 3 terabytes. And we're Elastic. I mean, Elastic that's basically where we start our discussions, is 3 terabytes. So I mean, there's pluses and minuses to it. But if you have a data set that's constantly changing, there is nothing better now and probably forever than a relational database. As we started grabbing more data, these relational databases built a new concept. So if you look at, for instance, Microsoft SQL, they now have that new wide column type capability. And the change here is that you can have these same spreadsheet type columns, and they're inside a single spreadsheet row key is what it's really called. And so you can have multiple of these in one single place. And that allows it to grow, where they can see larger scale type data sets. But you can imagine, as you add another layer, you have to take one more layer in order to get inside. That reduces your speed, that reduces your CRUD, create, read, update, delete, agility. There's pluses and minuses to that. You still have a lot of that ability, but it's just a little bit slower, a little more complex. And so, you know, there's use cases for both of these. Another one that came up as we started, as our CPUs got faster, as our ability to do more of this type of work is the NoSQLs. So what is NoSQL? If you notice, this is the data set that comes in, and it's very different. Whereas before, if we go look at it, if you have a dog, that dog has to have a breed. It has to have a color, period, and only one color. I mean, if you have 2 colors, it gets a little weird, right? So you have to have just one. Whereas with a NoSQL, you can have these things called arrays. This person, who's Paul Miller, they don't just have one profession. They can have an array of professions. They can have an infinite number of professions. And so it adds that little more features. You don't need city, but if you have it, you can add it to this list. You don't need cell number. Here is an object where you have a car and all the features of a car that are inside it. So a lot more complexity. As you look at this, just kind of think it's going to take more effort to compute this. Correct. It's not as good with CRUD. It's going to be a little bit slower, but with the speeds that we have for a lot of use cases, this is going to crush it. It's going to be able to grow. You're going to get much more than 3 terabytes, not petabytes, but you're going to get much more than 3 terabytes of this data, because with this type of methodology. So, pluses and minuses with it. The next one I want to share is the distributed file system. So what is distributed file system? You just have a file and you dump it somewhere. And obviously there's a lot more complex than that. There's ways to process it, to make it easier to search, but it allows you to search basically anything. And the data lake world really blew up when we moved into this distributed file system type methodology. Hey, look, let's dump all the files in one place, and then we figure out what to do with it, because we finally have the ability to put it in one place and look at it. That changed everything. It will, just like everything else, there's always going to be incredible value for this. What we found is it takes a lot of time to process that data. Sure, it's somewhere, but how do we know what iColor is, or we'll do IP address. So Cisco device is going to define their IP address. They're going to name it one way, whereas Palo Alto is going to name their IP address different way, whereas the DNS system, Cloudflare, is going to call it, does something else. And so we have to find a way to say, okay, where are all these IP addresses? Let's try and find it. Then we search. The query times take longer with this. Because the data is there, we can query it, and that has never been happened before, but it takes longer. You're looking at seconds of time, 50 seconds, 100 seconds. When you start bringing in more specific type queries, things that you're looking for, it's still in the tens of seconds that you're looking at to be able to query this data. But it's available. We can query it. I mean, that concept of can didn't exist until distributed file systems. We can look at petabytes of data, do queries on petabytes of data. This transitions us to the search engine, which is where Elastic comes in. So Elastic is all about, we bring in data. You can update it, almost never update it. This is more about time series type data. We are built for something called Slemming. What is Slemming? Slemming says if you search for climbing, it will also look for climb. It will look for climber. It will look for climbs. It will look for a capital C climb. It will look for all of those things at once, so you don't have to be as specific. And it's all about speed. These searches are less than a second. Because you don't really change it, you don't do that CRUD, because you have that Slemming already pre-built in advance, you can make queries that are less than a second for petabytes of data. So pluses and minuses. You're not going to be able to bring all the data in, because we do want it organized before it comes in, as opposed to like a distributed file system where you just dump it in there and you can look at it. I mean, we're totally generalizing here. I know that there are ways to work around that, but you need to organize in advance. But because it's already organized, because it's not going to change, we are able to look at larger data sets and make faster questions, requests for it. So those are the main data store types that exist right now. And I've been talking. I'm curious if anyone has any questions or thoughts before we go on to the next section. All right, give someone a couple more seconds here. So yeah, before we walk in, I remember the time when the data lake worlds really started getting big. It was maybe about 10 years ago or so. And I mean, it was revolutionary, right? But it was too much data. And I think we've now perfected how to do it, where we know what kind of data we want to bring in, and we purposely try and bring it in with more organization at this time. But yeah, it's a constant battle that we're having to figure out, okay, we have all this data. We need answers to this data. How do we do it? And that's what this next section, where we're really going to start talking about, is what are some of those new methodologies that we have. So let me talk about a couple actual use cases for these larger data sets that they have. So the first one we want to do is crowdsourced. What is crowdsourced? F-35s, they are all the rage right now, and they're kind of awesome. You go watch videos, they're pretty cool. They are a data magnet. They grab petabytes, I mean, just insane amount of data of a lot of different things as they're going out and about. Um, there are several groups who try to grab data off of the aircraft and be able to assess them, do some like performance assessments, some how is this part working? Is it not working? How is this system talking to this system? Some security cyber type components. The best one I personally found is this QRIP. This particular device is built to be placed on an aircraft. It's about this big. It's pretty small, and it's maybe like a kilo size. And as soon as the aircraft lands, within 45 minutes, all of that data is in the KM system, and it can be used by many different teams for many different purposes. These aircraft are very expensive, so there's a lot of evaluations to make sure that we're getting the most out of this product, out of that aircraft for every single flight that it does. The systems, as we talked about how there's many data stores that exist, so let me show you the data stores that are inside this KM system. So they have different data stores for different purposes. For more short-term type responses, you're going to have that MySQL. The SQL Server, that's that larger, that big table type methodology. Elastic is in there as well for the speed layer. You want to know the main purposes they have is as soon as the aircraft comes down, they want to look at specific alerts. They use Elastic to look at those alerts very quickly, make those alerts very fast. It's very easy to make alerts with Elastic very fast. The data is already organized in a specific way for specific large scale queries. So you can do that. When you think of like a Google search, Google has figured out how to allow us to search, and we could do so much with just Google search. Elastic does that as well. You know, it's a very specific way to search, but because it's all organized in a certain way, you can do that search, as opposed to when you get into that Hive and the SMB and NFS type world and at HDFS. That is, there's some teams, I know them very well. They do some really incredible, 3-day to 3-week type reports. I've seen them. They actually have shown how to. They've simulated the entire flight and everything that aircraft have seen on that flight. And you literally see the aircraft moving in a video. I mean, incredible, right? Not an Elastic thing. It takes about a week or two for them to be able to perform that type of activity. But you could see the value of that, because that data is available, you can do that type of work as well. So each of these data stores has its purpose for a different user, a different use case. And that's really what the value is you need to have to be able to see it in different ways. The next one I want to show is Big Data Platform. I actually was talking with them this week down in San Antonio. They are making changes to this. They are very excited about those changes. They are, I don't know exactly where they're going to go but I know that they're very interested in it. Big Data Platform, incredible concept. We want all the data in one single place. We want to be able to do all the interesting things you want to do with that data. And again, a lot of data stores, a lot of different ways you look at that data. So as the data comes in, it instantly goes into Storm. What is Storm? Storm is very quick alerting. So if very simple queries, they look at the data real time within less than a second, they'll be able to get that alert out for information. You can't do complex alerts. You can't look at whole history. You can't do, history is probably the biggest one. You can't look at the history. You just look at, was that a good thing that happened? Was that a bad thing that happened? But there's huge value to Storm. As soon as it's brought in to the locations, that data. First is back to that Hadoop type world where you're doing those multi-day, multi-week type reports, very unique, very specific, usually asked directly by a general, very important type reports, where they're doing a lot of code in R or Spark, be able to start doing those analytics. The other one is where the Elastic comes in. So Elastic, again, back to that speed layer, we know these specific requests. So what we're going to do deep analytics, but it's very specific to search. We're not making any changes. The data is already in the right format, allowing that to happen within Elastic. making cool little gadgets and gizmos and Jetty to be able to see what was done within Elasticsearch as well. So again, old platform, it's going to change, but this is what it currently is right now. Why is it changing? That is where we're going to walk into next, because the world is moving more towards this data mesh type concept. All of those big data sources, we've realized, I'm not going to say they struggle because they have a good use case, but we want to add to those use cases. They have done a very good job of specific use cases, but they are focused on a specific owner. When we start moving into like the data mesh type world, there are going to be many data sets, many data groups out there who are going to have their own domains of data that are in charge of their own things, and they want to control the data in the way that they want to control it. I look at it as, so here you can see a good example where we're going to have many data stores. Like for instance, in the space, there's going to be a team in the field that's going to have their data sets, and there's going to be a team that's at HQ, they're going to have their data sets. Infrastructure is going to have their data sets. Everyone's going to have probably a lot of overlap with that data, but they're going to want it in their way with their permissions, who gets to see what, when they get to see it. They want that control. That is very important to each of these groups. And I think that's a very fair thing. I liken it to a musician. So a musician is not going to practice at Carnegie Hall in front of a crowd. They're going to perform at Carnegie Hall in front of a crowd, but they're going to practice in the corner of their office or in their house for hours and hours and hours and hours and hours until they're ready for Carnegie Hall. And I think the same thing goes with data and people's data. As they figure things out, as they figure out what is best for them, what is the most valuable to them, they're going to make mistakes. They're going to have some really weird looking data that they're fine with because they get it, but they don't want that other group over there to make stupid decisions with that dumb data that was just being practiced on. And so the value here is that people want to bubble up data. People want to work together, but they want to look good. They want to have the data that they know is showing who they are the most available out there. So the data mesh concept is that everyone is going to have their ownership, their domains. And we want a way for each of them to be able to talk to each other. And there's a couple things that need to happen for that. So the first one I want to talk about is Elastic Common Schema. There is this Elastic Common Schema it's called Elastic Common Schema. It was written by Elastic, but it's for the community. It's for everyone. It's open source, completely on GitHub. Anyone can use it for any purpose. In fact, there are groups at DISA right now who use this as their baseline and are building their own schema with Elastic Common Schema, helping them with all the stuff that's already built. But there's going to be a lot of GOT stuff as well that they also want in their schema that we don't care about, right? Elastic is not going to care about that GOT stuff, but it's important to DISA. And so they're building a schema wrapped around us. And I think that's a good example of how the schema works. Why is this a value? It's a value because back to that IP address. When I have an alert and I want to see anything that happened on that IP address, I want to look at everything. I want to look at the Cisco devices. I want to look at our logs. I want to look at the firewalls. I want to look at everything at once. So if I put in the search right here, that IP address, I will see every single event throughout our enterprise about that IP address. Maybe not an IP address. What about like there was an attack and they used this specific file? I want to know every system that has ever seen that file. I want to see in the network, has any packet had that file in it? I want to see everything, the entire spectrum of where that file has existed in the past. That's the value of this common schema, where we can go back to all of these different systems, these silos, and if we can see all that data in one place, Elastic Common Schema allows us to search each of those places. Okay, so that's thing number one. Thing number two I want to talk about is the ability for each of those different clusters to talk to each other. So Elastic has something called cross-cluster replication and cross-cluster search. What are those? That means that if back to this system here, this group right here can decide if the headquarters of the air gets what they get to see, when they get to see it. That would be cross-cluster search. Sure, they own their own cluster. The aircraft team, though, would be able to query the C team for information. That's the value of cross-cluster search. Replication, I think a good example of that would be, let's say you have some bad connectivity out there. Replication allows you to, whenever the connectivity gets good, or when we have a moment when things are nice, that we replicate as much as possible to both sides, to the headquarters and to that off-site location as well, to be able to get as much information to both sides as possible. Now, Elastic is not going to be the owner of each of these data stores, and we don't want to be the data store owner of all these things. To our earlier point of this call, we can't do everything, and we know that. We absolutely know that. What we feel our place is that speed layer, where we have access to each of those data sets and people can search very quickly each of those data sets. I'll give it a good example. So Cisco, the end of their fiscal year, they do, I don't know the numbers, but it's an absurd amount of transactions. I mean, they are closing deals throughout the world at a level that is nearly impossible to really comprehend. I mean, thousands and thousands of transactions happen every minute. That is all in the relational database, and it should be, because that data constantly changes. It needs to be accurate. Relational databases are the perfect place for that type of data. There's another group of users who look at that data as well. They are constantly looking at that data to assess what is happening out there so they can know what they need to change, what they don't need to change. This group doesn't need perfect, exact data. What they do need, though, is speed. They need to be able to look at that data in under a second and see as much as they can of that data. They use Elastic as that speed layer, pushing that group away from the relational database, not adding more users to that relational database, pushing them away, but still giving them the information they need. And that's what I'm talking about with this speed layer, is that it's not affecting the data source. It's allowing all these other groups to be able to start integrating with this data. This creates what we call this cross-cluster domain type idea. And I'm going to show this in the next slide. I think will make a little more sense. So, and building this global mesh. So the idea of this global mesh is that we have all of these speed layers throughout the world, everyone owned and maintained by their own group. They get to decide what they share, what they don't share, who they get to share it with, all that information. That is bubbled up to all of the different groups who can holistically see this. And I'm going to show this in the demo in a little bit. The first one I want to share is this operator type at the mission level. They're looking at events that are happening throughout the world, being able to see the full attack spectrum that is happening. Oh, next one is that manager role. As they have real-time scenarios that they need to deal with, they need to create new dashboards very quick and do that more tactical evaluation of that thing. And I know I'm using words here. I'm using jargon that is very generic. It'll make more sense in the demo. And then the last one is that executive view. They need to make large decisions. They want that same data, being able to assess that data in one single place. So that brings us to our demo. Any questions before I walk into the demo here? So I'll again, feel free to stop me at any time. So this demo, I've built 3 Elastic clusters, and you could see the location of those clusters on the screen. One's in Belgium, one's in England, and one is in Finland. They're all using our Elastic Cloud at this time, each with their own permissions, all their own controls. We are going to assess an evacuation out of Amsterdam. Why Amsterdam? Because why not? Amsterdam always needs to be evacuated. So we're going to look at that evacuation from those 3 groups, from the tactical group, from that more commander type group, and from the general type group. All of this information is available to us in the cluster. Let me transition over there to there now. So here is that particular here is this dashboard. So we have all of the alerts in one single place that are happening. We have the pump team that is out in England. We have the consulting team that's out in Finland. And I can't remember the other team, but there's another team in Belgium, all with their own data sets. The idea here is that when there is an issue, like for instance, an evacuation, there are going to be many signals of interest that matter. And we're not going to be able to get all that data from one single place, but we want to bubble it all up into one location to be able to see it in one area. And that's what we're doing, is we have all these alerts from each of those groups into one single place so we can see the spectrum, the whole theater that is happening. We're noticing that there are a couple alerts that are happening. So as the analyst, look into here, I want to first, let me make sure I click on the right one. Yep. So first one I want to show is if we have that line one engineer, as they're looking at all of these alerts, there's no way that they can fix everything. They're not going to be that knowledgeable. No one's knowledgeable enough to look at the pump team and the consulting team and I mean, all of those teams and be able to fix all those problems. So we give them, and this is all in Elastic, by the way, we give them all of the information they need to be able to perform their mission. So here's the rules that they need to be able to do. Here's the assignments they need to do when this alert goes off. This particular alert is that there was a timber response. Looks like someone has been nefariously changing the direction of our pumps. We do a validity check, be able to assess if this is actually the case. Looks like the event is happening. Who they need to contact. And then as they go down the rest of their root cause analysis, all of the information they need in one single place. This particular alert in the past we have seen is often a supply chain issue. Here we can see that pump every time it's changed hands, every time it's had maintenance, all that information in one place, what the current version is compared to the desired version. The instructions ask that this line engineer, again, they're not going to be experts at everything, so they need to follow the instructions. They ask them to look at the version. We notice the version is not up to date. So letting us instantly know that the reason this happened, that root cause analysis, is that there was a bug, the nefarious actor gained access to this pump because the version had not been updated yet. Oftentimes, that's very common, by the way. I mean, a hacker will look laterally, try to find a specific system that might not be up to snuff and then go after that system. So that is from that line engineer holistic level tactical type activity. But now I want to move into, if we are like a captain, we are dealing with this actual evacuation. And what I'm going to show you here is an evacuation map. I purposely, I made sure that I took less than 10 minutes making this map. And I did that on purpose because if I'm in charge of an evacuation and I need to do all the tactical of this, I don't have time to make that 3-day map. I need to make something very quick. I have access to the data already. Just bring it into this map and start looking at it. And here we can see all the different buildings that are of most concern. Reds, yellows, greens, let us know which ones are the biggest issues, and the location of our helicopters at that time. If we hover over a helicopter, it'll tell us how much fuel it has, what the actual helicopter name is. As I look at this, I think, you know what, this is good. And I'm going to show you, what I'm going to show now is how fast it is to iterate on this. I look at this and say, this is good, but I would like to know how much capacity that helicopter has. As they're making all of these changes, I want to know if, looks like, hold on a second, it's not, it's thinking that the zoom is in the wrong area. What's going on here? There we go. So here I can add a new tooltip and available capacity. I add that to the tooltip, click save. And now, as I hover over this, it will now show me the capacity of that helicopter. So very easy to iterate, make changes to this map, whatever I'm needing at that time, gives me that ability to look at this information. As you notice, this has nothing to do with IT. Elastic has a great background with IT, but we are a search tool, a data store tool. Bringing this type of data, I had this conversation earlier this week. We went very deep into how we would get this type of data. We have methodologies, often most of them are on GitHub. to be able to look at this type of information, be able to see this information and bring it in to assess it with that IT, cyber, or performance type information. So that's from the, okay, we're looking at this at one single moment, an actual scenario. The last one I want to do is if I'm a general. And what I mean by that is I have this evacuation and I can't send everyone out there. This issue is going to be going on for a few months, and there's going to be things that need to happen as we really fix this problem. There was a flood and we got to remove the water and remove the mud and all of that. I want to know what I can get to that location and how fast and who. And that's where we're going to walk in with this mission readiness. So what is this dashboard? This dashboard is, I am in charge of many teams. So each of these colors is a different team, and they have different specialties. I can look at their training, see what their scores are on their training to see who's a specialist at what. If I bring everyone out there and I give myself 181 days, these are all of the different resources I would have. But I can't send everyone out to every single activity. I need to pick and choose. And so what I'm going to do here is I'm going to say, I'm going to bring that team, and it's still doing it, the Zoom thing. Let me click into this. Man, it's kind of weird. All right, pick that team, and then if it will let me, it keeps thinking I'm in Zoom and it's wanting me to chat, and I don't want to chat. I don't know if you guys can see that or not. Let me move this for a second. Well, we'll just go with that team for now, I guess. Nope, it won't even let me chat. It's going to update this screen if I can get out of the Zoom issue. It's Zoom, it's kind of a weird situation. But it would update this map completely to what would we then have available in the resources. We can change the timing as well for the system and be able to look at what the changes would be as well. So it's filtering all of our teams and be able to assessing what would it look like as well. Not sure why that's happening, but I'll just keep it at this for now.